Hi guys, welcome to my channel MTech. In this video we discuss about diodes, and we discuss diodes introductions and parts of diodes and their applications. Number 1, the ideal diode. Current voltage characteristic. The ideal diode may be considered to be the most fundamental non-linear circuit element. It is two-terminal device having the circuit symbol of figure 4.1a. The IV characteristics shown in figure 4.1b. The terminal characteristic of ideal diode can be interpreted as follows. If a negative voltage relative to the reference direction indicated in figure 4.1a is applied to the diode, no current flows and the diode behaves as an open circuit. Diodes operated in this mode are said to be reverse biased or operated in the reverse direction. An ideal diode has zero current when operated in the reverse direction and is said to be cut off or simply off. On the other hand, if a positive current relative to the reference direction indicated in figure 4.1a is applied to the ideal diode, zero voltage drop appears across the diode. In these words, the ideal diode behaves as a short circuit in the forward direction. It passes any current with zero voltage drop. A forward biased diode is said to be turned on or simply on. From the above description, it should be noted that the external circuit must be designed to the limit the forward current through a conducting diode and the reverse voltage across a cut-off diode to predetermined values. Figure 4.2 shows two diode circuit that illustrate this point. In the circuit of figure 4.2a, the diode is obviously conducting, thus its voltage drop will be zero and the current through it will be determined by the plus 10 volt simply and the 1 kilo ohm resistor as a 10 milliampere. The diode in the circuit figure 4.2b is obviously cut off and thus its current will be zero, which in turn means that the entire 10 volt supply will appear as reverse bias across diode. The positive terminal of the diode is called anode and the negative terminal is cathode. A carryover from the days of the vacuum tube diodes, the IV characteristic of ideal diode, conducting in one direction and not in the other, should explain the choice of its arrow-like circuit symbol. As should be evident from the preceding description, the IV characteristics of the ideal diode is highly nonlinear. Although it consists of two straight line segments, they are at 90 degree to one another, and a nonlinear curve that consists of straight line segment is said to be piecewise linear. If a device having a piecewise linear characteristics is used in particular application in such a way that the signal across its terminal swings along one of the linear. Here figure 4.1a anode cathode. This is forward bias. This is a graph of forward bias diode, and here voltage will be uh, 0 and I will also 0. I greater than 0, voltage 0. The diode, a diode circuit symbol B, IV characteristic C, equivalent circuit in the reverse direction. D equivalent circuit in forward direction. Figure 4.2, the two methods of operation of ideal diodes and use of an external circuit to limit the forward current and the reverse voltage. This is forward and this is reverse. Segments. Then the device can be considered a linear circuit element as far as that particular circuit application is concerned. On the other hand, if signals swing past one or more of the breakpoints in the characteristic, linear analysis is no longer possible. Topic 4.1.2, a simple application, the rectifier. A fundamental application of diode, one that makes us of its severally non-linear IV curve, is the rectifier circuit. The circuit consists of a series connection of diode D and a resistor R. Let the input voltage V1 be the sinusoid shown in figure 4.3b, and assume the diode to be ideal during the positive half cycle of the input sinusoid. The positive V1 will cause current to flow through the diode in its forward direction. It follows that the diode voltage Vd will be very small, ideally zero. Thus, the circuit will have the equivalent shown in figure 4.3c. The output voltage VO will be equal to the input voltage V1. On the other hand, during the negative half cycle of V1, the diode will not conduct. Thus, the circuit will have the waveform as shown in figure 4.3c. Note that while V1 alternates in polarity and has a zero average value, V0 is unidirectional and has finite average value or DC components. The circuit of 4.3a rectifies the signal and hence is called a rectifier. It can be used to generate DC from AC. We will study rectifier circuit in section 4.5. Figure 4.3a. Figure 4. This is forward direction diodes, and this is graph B C 4.3 C 4.3D. This is full wave half wave rectification graph. Rectifier circuit input waveform equivalent circuit when V1 greater than equal to 0, equivalent circuit when V1 smaller than equal to 0, output waveform. Here this is exercise question 4.1, topic 4.2, topic 4.3, example 4.1, and solution also given. And we close our lecture, and next topic discussed in another video. Don't forget to subscribe my channel MK Tech.